Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're going to talk about Pythagoras' theorem and prove why the result is true. In order to do that, I need a few skills from you. The first one is, imagine you had the following square. Could you pause the video and state an expression for the area of the square with side C shown below? Well, the area for this would be C multiplied by C, which we write as C squared, right? What about this one here? State an expression for the area of this square. It's got side a plus b. Well, it would be a plus b multiplied by a plus b, wouldn't it? Which we write as a plus b all squared. That would be our expression for the area of something like that. And lastly, what would an expression for the area of the triangle shown below be? Pause the video and double check you know that. Well, the formula of a triangle like this is the base multiplied by the perpendicular height divided by 2, or half the base times the perpendicular height, which in this case would be a half multiplied by a, which is the base, multiplied by b, which is the perpendicular height, which we would write as a half ab, something like that. Alright? Fantastic. Now let's get going and prove Pythagoras' result. Okay, suppose I had a right angle triangle here with sides A, B and C, C being the longest side and A and B being both shorter than C. Imagine I took that right angle triangle and I copied it exactly, and I rotated it 90 degrees clockwise and placed it exactly in position so that the base of that triangle there, which is length A, exactly was in line with the B that is in the first triangle. Suppose I did this again. I copied our triangle here, I rotated it another 90 degrees and placed it to form another perfect line along the top there. And finally, suppose I copied it one last time, twisted it another 90 degrees and placed it exactly there to form a line along the bottom and a line along the side there. So what we have created here is a large square, and if I start in that corner there and I drag this down, you will see that that there is a square. In particular, if I take away these triangles in here, you can see I've created a square. Now the question is, what is the area of the larger square? Well, the area of the larger square on one hand is this side here, which is this length A add this length B, multiplied by this side here, which is A add B. So on the one hand, we could say that the area of this square is A add B all squared, right? Fantastic. But on the other side of things, what we could say is we could say it is equal also to the area of the square on the inside here, right? Added to the four triangles. One triangle, two triangles, three triangles, and four triangles. Couldn't we? So we could say that this area that we've already found is at the same time it's equal to this square here in green, which is c squared, add 4 lots of the area of this identical triangle. So 4 lots of the area of this triangle, which we know is a half AB. Right? So let's expand the left hand side, and if we do that we would get a squared plus 2ab plus b squared, and here we've still got our c squared, and here 4 multiplied by half is 2, so we've got 2ab. Now we could subtract 2ab off both sides and it would eliminate that 2ab, so subtract 2ab from here and subtract 2ab from here, and you will see that we have got ourselves that c squared is equal to a squared add b squared. And that there is Pythagoras' theorem. Let me remind you of what we started with. We started with a triangle here with sides A, B and C, and it always turns out to be true that when you have a right angle triangle, the longest side, C, when you square it, is always equal to the other two sides squared added together, a squared add b squared. That is always true. And that is the result which we'll formalize now. So, for any right angle triangle, as long as it's right angle triangle, it's got a 90 degrees as one of the angles, and it's got shorter sides A and B, so it doesn't matter what A and B, as long as A and B are the two shorter sides, and longest side C, which we call the hypotenuse, and it's very important you remember that the hypotenuse is the longest side of a triangle, it is always true that this holds. C squared, the hypotenuse squared, is equal to A squared plus B squared. And sometimes we say the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now, sometimes how would you know which one's the hypotenuse and which ones are the shorter sides? It always turns out, always, that the longest side, the hypotenuse, is always opposite the 90 degrees. It's opposite the 90 degrees. So that can help you identify the hypotenuse. And the two shorter sides, well, the 90 degrees is always the angle between the two shorter sides. So when you see the 90 degrees, you know that the side beside it and the other side beside it are always the two shorter sides, and the one opposite it is always the hypotenuse, the longest side. But that's Pythagoras' theorem. The square of the hypotenuse, c squared, is equal to the sum of the squares of the other two sides, i.e. a squared, one of the shorter sides squared, add b squared, the other shorter side squared. And in the future videos we are going to apply this rule and use it in several cases. Thanks for watching.